Hello everyone. In my earlier video, I mentioned that glycolysis is a catabolic pathway in which glucose breaks down into pyruvate. The glycolysis involves 10 reactions catalyzed by enzymes, and all these reactions occur in cytosol. Glycolysis occurs in two stages. The first stage is preparative phase, where 2 moles of ATP per mole of glucose are used up. The second phase is payoff phase, where the glycerol 3 phosphate gets oxidized to pyruvate. The overall reaction of glycolysis is conversion of 1 mole of glucose into 2 moles of pyruvate, with the net yield of 2 moles of ATP and 2 moles of NADH. In this video, let us discuss the 10 reactions of glycolysis. Out of 10 reactions of glycolysis, 3 reactions are irreversible. 2 reactions are the examples of substrate level phosphorylation, and 1 reaction is a redox reaction. The first reaction is catalyzed by hexokinase, an example of transferases. Hexokinase catalyzes the transfer of high energy phosphate group from ATP to glucose, resulting in the formation of glucose 6 phosphate. The second reaction is a reaction involving isomerization. The enzyme phosphoglucose isomerase or phosphoglucomutase catalyzes the conversion of glucose 6 phosphate into fructose 6 phosphate, an isomer. The third reaction of glycolysis is catalyzed by phosphofructokinase, a transferase enzyme. It catalyzes the transfer of high energy phosphate group from ATP to fructose 6 phosphate, resulting in the formation of fructose 1,6 bisphosphate, in short FBP, also referred to as FDP. This is the second irreversible reaction of glycolysis. The first being the very first reaction of glycolysis. The fourth reaction of glycolysis is the breakdown of fructose 1,6 bisphosphate into glycerol 3 phosphate and dihydroxyacetone phosphate. A hexose phosphate is broken down into 2 triose phosphates. The reaction is catalyzed by aldolase, an example of lyases. The fifth reaction of glycolytic pathway is an isomerization reaction catalyzed by triose phosphate isomerase. This enzyme catalyzes the conversion of dihydroxyacetone phosphate into glycerol 3 phosphate. It is glycerol 3 phosphate that continues in glycolysis. In this way, the 6 carbon sugar is broken down into 2 molecules of glycerol 3 phosphate by a sequence of 5 reactions. Now, the 2 moles of glycerol 3 phosphate formed per mole of glucose will continue in glycolytic pathway in the second stage of glycolysis. The second stage of glycolysis is the payoff phase. The sixth reaction of glycolysis is catalyzed by glycerol 3 phosphate dehydrogenase. This enzyme catalyzes the oxidation of glyceraldehyde 3 phosphate into 3 phosphoglycerate. It is also followed by phosphorylation, resulting in the formation of a high energy acyl phosphate bond. So the product of the reaction is 1,3 bisphosphoglycerate or 1,3 DPG. It is an example of a redox reaction catalyzed by a dehydrogenase. In this reaction, NAD plus is reduced to NADH. 1,3-diphosphoglycerate that is formed in reaction number 6 is a high energy phosphate or a high energy compound. It contains a high energy acyl phosphate group. The enzyme phosphoglycerate kinase catalyzes the transfer of high energy phosphate group from 1,3-DPG to ADP, forming ATP. During the reaction, 1,3-DPG becomes 3-phosphoglycerate. It is an example of substrate level phosphorylation. Reaction 8 of glycolysis is an isomerization reaction. The enzyme phosphoglycerate mutase, an isomerase, catalyzes the transfer of phosphate group from third carbon to the second carbon. Thus, 3-phosphoglycerate is converted into 2-phosphoglycerate. The ninth reaction of glycolysis is catalyzed by the enzyme enolase. It catalyzes the removal of a molecule of water from 2-phosphoglycerate, resulting in the formation of an enoyl phosphate, that is phosphoenol pyruvate. This PEP that is formed in this reaction is a high energy compound. The 10th reaction of glycolysis is catalyzed by pyruvate kinase. Phosphoenol pyruvate formed in reaction number 9 is a high energy compound. It contains high energy enoyl phosphate group. That high energy phosphate group from PEP is transferred to ADP, resulting in the formation of pyruvate and ATP. This is the second example of substrate level phosphorylation in glycolytic pathway. There are two reactions of substrate level phosphorylation in glycolytic pathway. This is the second one. The first one being 1,3-DPG becoming 3-PG, where the high energy phosphate, acyl phosphate of 1,3-DPG is transferred on to ADP to form ATP. That is the first reaction where substrate level phosphorylation occurs, and this is the second substrate level phosphorylation reaction of glycolysis. Thus, by a sequence of 10 reactions, 1 mole of glucose will be converted into 2 moles of pyruvate, during which there is a net yield of 2 ATPs and 2 NADH. The overall reaction of glycolysis is given here. Glucose plus 2 moles of ADP plus 2 moles of NAD plus, giving 2 moles of pyruvate, 2 moles of ATP and 2 moles of NADH. So the net yield in terms of ATP per mole of glucose in glycolytic pathway is 2 moles of ATP and 2 NADH are produced. If the organism is aerobic, these 2 NADH undergo oxidation in electron transport chain, producing few more ATP molecules.